boiling oceans may lurk beneath the ice of the solar system's smallest moons. Scientists discover water that boils without being hot. Humans remain confused by pressure. Greetings, fellow observers. Commander Zix here with breaking news from Earth, where scientists have just discovered that the solar system's smallest ice moons might be hiding boiling oceans beneath their surfaces. Not boiling because they're hot, mind you, but boiling because pressure physics works exactly as thermodynamics predicted. So here's what happened. A study published in Nature Astronomy reveals that Saturn's moons, Mimas and Enceladus, plus Uranus's moon, Miranda, could have oceans that literally boil when their ice shells melt from below. Max Rudolph from UC Davis led the research explaining how melting ice causes pressure to drop so dramatically that water reaches its triple point at 273.16 Kelvin and 611.7 pascals, where solid ice, liquid water, and water vapor can all coexist simultaneously. Translation: these tiny worlds have hidden seas where water exists in 3 states at once. Simple thermodynamics for you. Apparently, humans are shocked. Let me paint this picture for you, space observers. These moons experience tidal heating from their parent planets, creating cycles of warming and cooling over millions of years. When ice shells melt from the bottom up, the pressure drops because ice is less dense than liquid water is. The pressure can plummet low enough to hit that magical triple point where physics stops playing by intuitive rules. This explains the bizarre surface features seen, like Miranda's coronae, those rigid valleys, and the towering cliffs that the Voyager 2 photographed back in 1986. Scientists looked at those images for nearly 40 years without understanding what created them. Meanwhile, the equations were sitting there the entire time. But wait, it gets better. Mimas, Saturn's so-called Death Star moon measuring less than 250 miles across, looks completely geologically dead on the surface. Pitted with craters, no volcanic activity, nothing. Yet a wobble in its orbit suggests a hidden ocean lurks beneath the corpse-like exterior. The moon appears inactive specifically because its ice shell does not crack during thinning, reconciling a dead surface with a liquid interior. Apparently, looking boring is the perfect disguise for hiding an ocean. Here's where it gets truly fascinating. Size determines everything in this scenario. Larger ice moons like Titania cannot reach the triple point because their ice shells crack before pressure drops sufficiently. Only the smallest moons, the ones humans assumed were least interesting, can sustain these boiling ocean conditions. The cosmic joke writes itself. Your species spent decades searching for water on the biggest, most dramatic worlds, while the tiniest moons were hiding the most exotic water physics. Your species mastered thermodynamic textbooks, built spacecraft, photographed distant moons, then spent 40 years puzzling over surface features that basic pressure physics explains perfectly. This is Commander Zix reminding you at home that the universe's most fascinating phenomena often hide in the smallest places. And equations do not care whether their predictions align with human expectations.